Apart from this, what they can ask you is change in momentum and impulse, okay, which would include force into time. I guess this part is easy. The only trick over here, my lals and my lalis or my kids, would be that remember momentum is a vector quantity and so is velocity. So if they have mentioned, now this is the keyword, if the object collides and bounces back, if it bounces back, then your change in momentum formula, which you normally write as final minus initial, becomes this. You need to add the momentum because my velocity is a vector quantity. So there is a sign convention associated with it. But you may directly use this formula to get the change in momentum of any body which is bouncing back. That's the only catch over here. But if it's collision, again, I will categorize this into two types. Like you will study further, either it would be a moving collision where two objects, either both moving or one moving, one stationary, collides, and after collision, they move with two different velocities. Directions may be same, may be different. Or it might be a sticky collision where the objects stick together and then they move together after collision. For both of them, the formula or the logic remains the same. You have to use your conservation of momentum. I'll not derive the formula. I'll just give you all the formula. So it is m1 u1 plus m2 u2 is equal to m1 v1 plus anybody m2 v2. Now, a lot of terms over here might look very overwhelming. So what I prefer is make a table. Okay. This is object 1, object 2. You have m, u's and v. Your mass before and after collision, of course, will remain the same. Your initial velocity, you will note it down, and your final velocity. And after you are done with this, you will substitute. Okay. Also, if you look at the pattern of questions, it will follow the same pattern most of the times. They will tell you to first find the total initial momentum of both the objects. If the object, if object 2 is stationary, they will tell you to find the initial momentum of object 1. And then they will tell you to find one of the missing terms. Most of the times it is velocity. We clear with this? This is what you will do for moving collision. However, if the objects stick to each other after colliding, then you need to remember they move with the same velocity. So instead of V1 and V2, you will just replace it as V. You can do the math, take V common, and then proceed with the solution. We clear with this, or was I too fast? Do let me know if I'm fast.
I think that was okay. So the next question that we have is, how do we draw the electrical diagram?
Electrical diagram, as in, beta, can you be a bit more specific? You're talking about electric fields, or you're
Uh,
talking about circuit diagrams?
Circuit.
Circuit diagrams. Okay. So for circuit diagrams, you will really need to read the question. The trick about IGCSE is reading the question. Unfortunately, a lot of kids skip that part. Okay, so if you read the question, they will clearly mention where exactly they need the component basically. Just remember one thing, voltmeters you can't connect in series. Okay, because later when you study how a voltmeter is made, you will see that its resistance is very high. And ammeters you cannot connect in parallel. That's the only thing you need to know. Also look for the keyword where they want you to measure the voltage or potential difference and which current are they asking for. Like if it is a circuit which involves branches, like a random circuit, if I may draw, these are your resistors. Yep. See, I have got four resistors. You need to be very specific, or rather, when you're reading the question, be very clear where exactly they want the current. So if they want the current across resistor 2, you go back to your basics that in series circuit, when components are one after the other, the current remains the same. So it could be anywhere in this red wire. If they want the voltage across the component 2, you cannot do this. It needs to be across the resistor and not in series. And if they want total current, then you may use this blue part, either before or after the branching ends. Normally they ask this in ATPs. Okay, anything else that you would like to ask over here, Beta?
Sir, can you refer the notes for the combined science physics?
Can I refer to the notes? I don't really have it. If you can send a screenshot in the group, please.
No, I'm asking for which note should we prefer for combined science
Oh,
physics.
for which notes should you prefer? What I tell my students is to make their own notes. So, whilst you have a couple of reference books, I would recommend you to go through the reference book. I don't know if you kids are practicing this or not, but this is what I refer or I tell my kids. I'll show you just a minute. Where is my syllabus copy?
Actually, this session is not for combined sciences physics. It is for IGCSE physics
General
coordinate.
physics, yeah. But
Because
anyway, I guess this will be.
yeah, so I
No,
was
go ahead,
just
go ahead. So sorry, so sorry.
saying that this is not for combined sciences. This,
Combined, yes.
this is for IGCSE coordinated sciences. So it's not for 0653.
But yes, for everybody, it's always better to sit with this copy of syllabus because this is going to be your Bible until you clear your grade 10 exams. A lot of pointers are mentioned here. So browse through it, irrespective of the course you're doing, browse through it and make sure you know each and every pointer.
Excuse me, sir, I had a doubt.
Hmm.
So can you please explain how to draw the resultant force diagrams to determine the magnitude and direction of the resultant force?
Okay. So if you people read the syllabus now, this resultant force has been reduced to an angle which is 90 degrees, which means the two forces will be perpendicular. So let's assume this is a box full of chocolate. You are trying to pull it with a force of 5 Newton, and your friend is trying to pull it at an angle of 90 degree with a force of, let's assume, 6 Newton. Now, because they're at angles and this is vectors, you cannot really add them directly. So that is where vector law, the triangle law comes in, right? Okay, so the angle is 90 degree. What you need to know is when two vectors are at 90 degree, the resultant is basically the third side. Okay, which
Okay.
means your
Yeah.
hypotenuse over here is your resultant. And therefore, if you
Um,
read the syllabus, it's mentioned either draw or calculate. Go ahead, tell me.
Sir, what about the parallelogram law of vector addition? Like, is that in our syllabus right now? Where
It's in your syllabus, but what you need to know is the parallelogram rule is just an extension of the triangle law. So what basically is the parallelogram rule? You draw two vectors, correct? This is going to be a
yes, sir.
6 Newton, 5 Newton. Similar, you construct 5 Newton over here. This automatically becomes 6, and the resultant is your diagonal,
Magnitude.
right?
I mean resultant.
So if
Yes.
resultant, so if you erase this, there you go. That's your triangle law. So you don't need to construct the entire parallelogram. I believe that's waste of time. Rather, just finish it off by making two sides of triangle. The third side automatically becomes your resultant.
The yes.
Okay,
Okay.
now direction. Sorry, go ahead. Can I just finish this beta?
Yeah, yeah.
Because
So,
this is where a lot of them go wrong.
yeah, yeah, yeah.
Now the direction. All of you all will write up, down, east, west, northeast, southeast. You cannot do that. See, you will study when you talk about vectors, it gives you the liberty to switch sides, to use any orientation. But irrespective of what you do, these angles that are made, they do not change. So your direction will always be the angles your resultant is making with two vectors. If you look, this is my vector 1, this is my vector 2, and this is my resultant. Okay, and these are my two angles, theta 1 and theta 2. So either you will measure
Sir,
theta 1 and theta 2. Tell me.
So the direction is not like north, south, east, west. It's actually
It's
the
never
angle
yes.
which is
Perfect.
okay.
Unless they tell you that you have a load which is suspended by two strings, then it's very obvious that your resultant is going to be upwards. Because then they ask you resultant with respect to the direction of weight. Okay, so for every other
Okay.
question, you will measure angles, and you kids need to write both because at times you get confused कि ये angle पूछा किसके साथ है. So it's always better to be on a safer side, write both. Cambridge
So,
is
but
not going to penalize you for it.
so in
Mhm.
most of the questions, they are only given like there's only one blank for the direction. So we
Doesn't
should write
matter.
both the angles.
Always write both.
Okay.
Okay. I'll again repeat, Cambridge will not penalize you for it. Unless your answers are contradicting, you will not be penalized, huh? Which means no negative markings. So whatever
Okay.
is correct, they will have to give you marks. Go ahead.
One of the next, one of the person in the chat box have written also when the swimmer pushes his legs against the wall exerts a force on the swimmer's legs. How does swimmer move
Mhm.
if the two forces cancel?
My Lal, a very big misconception over here. See, when you talk about the third law of motion, you're talking about two objects. So when I am exerting a force on the wall, or visualize yourself sitting on the office chair. I believe most of you all in your house have got office chairs, right? For the kid who asked this, do you have a chair with wheels in the house?
Yes,
Perfect. If you sit on it, you push the walls. Where do you go?
backwards.
Exactly. That's the answer to your question. What you need to know is the force that you exert on the wall, the same force the wall is exerting on you, right? So your change in momentum and the change in momentum of the wall will remain the same, but you will not see the effect on the wall. That's because of the inertia of the wall. We clear? Or its change in velocity is so small compared to the mass, or the acceleration is so small compared to the mass that the effect is negligible.
Yes, but then why wouldn't if the if a car is moving that time it happens like there are two forces and the car's velocity changes or it stops.
No, 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 no. Hold on. Can you repeat again? What was this about?
So suppose a car is moving and there are two forces acting on it like they're
Hmm.
equal to each other. There is no acceleration. If it is stationary,
Huh.
the forces are equal.
My Lal, you okay, okay, I get where you're coming from. You're talking about that there is a car. Okay, this
Yes,
is my
I
car.
think,
There's a
yeah,
forward force, there's a
constant
backward force.
velocity, right?
This
Yes,
is what you're
yes.
talking about. Okay, so you are telling me that you are pushing the object. There are two forces. But my Lal, these two forces are acting on the car itself. When you are pushing on the wall, you are exerting force on the wall, correct? The
yes,
same force the wall exerts you. Now that force that the wall is exerting becomes your driving force. ये पार्ट समझा आपको?
yeah. But then
Where is your
even
driving force? Uh-huh.
but then the road exerts a force on the wheels, causing friction. That's also another object.
Yeah. Yes.
But then why doesn't the car stop? Like it's
Oh,
too
you're talking about when the forces are balanced, why does not the car stop?
yes,
This is what you're talking about, right? Now,
yes,
Mailal, there is something which is known as inertia, which you people have studied. Okay,
yes,
but there are three types of inertia, out of which one is inertia of motion. That if the object is moving, it will continue to move. Where are you from? India?
I'm from India.
Okay, perfect, perfect. So have you seen people just jumping off the moving bus?
Yes, they do.
I will not recommend anyone to do that. That's stupidity. But whenever they jump, do they come to a standstill immediately?
No, they would jerk.
Hmm, exactly. That's inertia for you, my friend. Okay. So for the car, because it's, or rather, it's moving because or it is following inertia. Remember, every object around you would love to be in a state of rest or would love to move.
Yes,
Okay, that's because of the mass that it possesses.
Yes.
So the car keeps moving because of this inertia, unless your backward force becomes more. It's only then where your car stops.
Yes.
Okay, or if I have to put it in terms of work energy, which will make it even more clear, see the car is moving because there is some chemical energy getting converted to kinetic energy. Can I see this?
Yes.
Okay, for the car to come to rest, it needs to lose all its energy, which means the backward force needs to be larger than the forward force. The greater this force, the sooner the car comes to rest.
Yes.
This is one misconception that you'll have when it comes to parachutist question as well. Can I ask you a question?
Yes.
Yes,
Okay,
sir, of
so
course.
Zindagi Na Milegi Dobara, Hrithik Roshan jumping from the parachute. Sorry, jumping from the plane, correct?
Yes.
The moment he opens the parachute, what's the resultant motion or where will he go?
Up. He would still go
Upwards.
downwards.
Mm-hmm. Upwards or downwards?
He would go downwards, but resultant force would act upwards.
The same logic happens here, beta.
Lot of
There
people
is a forward force. Uh-huh.
lot of people just watch videos on someone filming somebody parachuting, and they open the parachute, he appears to go upwards. In reality is going
Correct.
downwards.
Absolutely, because motion is relative.
Yes, that's why.
I think
Okay.
Excuse me.
So remember, for an object,
I think that's because it's an illusion when the air resistance comes in role. So suddenly the speed
correct.
slow, so it gives an illusion of the person going upwards for a few seconds.
Exactly. Exactly. Okay. So an object will not stop or come to a standstill when the forces are balanced. If you can prove it, very good. You get a Nobel Prize. But technically, because the object already has speed and now my forces are balanced, there is no external work being done. So my speed will not change. We clear
Excuse
with
me.
that?
Sir, why does the switch have to be fixed in the live wire, non-neutral wire?
Oh, that's very basic, my lal. What's the role of a switch and what's the role of a live wire?
Live wire have to carry current.
And what's the role of a neutral wire?
It is at zero voltage so that the current should move from live to neutral.
Basically to complete the circuit, right?
Yeah.
So if your switch technically is beyond the live wire, imagine what will happen. No, beyond the component, I'm so sorry. Imagine what's going to happen.
So there will be no current. Suppose I open the switch in the neutral wire, then no current would even pass through the live wire itself.
The thing is, there will be still. So basically, how it works is if you are having your switch on the neutral wire, let me put it this way, the entire functionality of the circuit changes, beta. Your component will not, what do you say, or completely de-energize, which means even when you have switched off the circuit, there will be some power dissipation which will remain, which will eventually cause harm to your component. And also, beta, if let's assume it's beyond the live wire, sorry, it's your switch is beyond the component, and if there is anything wrong with the wiring, even if you touch the component, you are going to get a shock. Are you understanding this?
Yes, like it is live, the
So
component.
it's live, exactly. And if I handle the component, let's assume I am ironing my clothes, a t-shirt. Okay, even if I have switched it off, when I technically touch the component and if there is anything for wrong with the wiring, I complete the circuit. I become the ground wire. I'll get roasted. You don't want that.
No.
You understand? Exactly. And hence, that's the answer to your question.
Sorry to interrupt, but
Yeah, yeah.
we have many sessions lined up, and that half an hour has gone. So what we can do is, a lot of students have sent their screenshots of the doubts in the past papers.
Please,
So,
please, yes.
sir, I believe you are using a tab, right?
Yeah, I am.
Yeah, so I'll just share my screen for a few seconds, and you can click the screenshots of all of the question, and then you can share and explain if that works.
Works, works. So I'll just stop sharing. Go ahead.
Yeah, just a second. Is my screen visible?
It is, it is.
Okay. This is the first question. You just click the screenshots of
So
all.
I'll just take a screenshot of this.
Yeah,
Just
and
a minute. No,
just
no, no. Can you go back? Can you go back?
yeah.
Just a minute, beta. Where is my smart select? Mm, I'll just download this. Perfect. One done.
Okay.
Bayfront. Okay. Yeah, this was also one doubt that kids had. So I'll just take this. No, no. Can you go back? Can you go back, beta?
Okay. Okay.
Yeah. Uh, and yeah. The next one. Now, unfortunately, this is out of your syllabus, but you can solve it by equilateral triangle method.
Okay.
So I'll take a screenshot of this. No, wait. Just a minute, just a minute, just a minute. Sorry, sorry, sorry.
Okay.
Can you go back, beta,
Whoever
to
sent
the
this,
previous one?
yeah, just a second. Whosoever sent this, please send it in a horizontal way. Anybody who sends in a vertical way will not be, possible for us to. Yeah, this is the one.
Yeah, this one. Just a minute. So I'll just take a screenshot of this. Okay. Yep.
Okay. Uh,
Before you do the past papers, could you please explain the centripetal force?
I'll do that. I'll do that.
this. Okay, we have taken this. Just a second. This is also another one.
No, again, see, if you go back, can you show me the diagram, beta?
Yeah.
Yeah. The next question, the next page. So the first part, momentum is there. Momentum. Again, this is out of syllabus because the angle isn't 90 degree.
Okay. I think we can skip the ones which are
Okay.
up.
For these questions, if you still want me to solve them, just put it in the group. As in when I get time, I'll go through it.
Okay.
Okay.
We
I'll just open my photos and I'll get all of them here.
we also have another few more.
Okay. We have one more. Just a minute.
Two to
Okay.
three.
So select. Which one? Two and three both? I'll take both.
Okay.
And let me just open this. Attach image.
That's enough for,
Okay.
Okay.
So one, two, three, four. There's one more. Just a minute, beta. Iron core transformer. Okay. Smart select. Just a minute, beta. Mark this as an FAQ, the last one, the iron core transformer.
Okay.
So I'll just
If
image.
also wants to send that out. I think rest can be done in the group. Right now we can, just do some of them.
Okay, so I start sharing my screen, beta.
Yes, sir.
So I'm just sharing and I'll go back here. Where did it go? Okay, so this one, electromagnetic induction, what you need to know is whenever you have a moving magnet next to a coil or any conductor or vice versa, EMF is induced. We clear? So when you pull the magnet down and when you release it, when you're releasing it, what will be the motion of the spring? It's going to oscillate, correct? Vertically up and down. which means your coil that is fixed. This is my coil with a galvanometer, and this is my magnet which will be moving up and down. As the magnet moves, your number of field lines associated with a conductor changes, which you kids call as the field lines being cut. So the field lines are being cut and EMF is induced. Now, because the magnet is oscillating up and down, the direction in which the field lines are cut will change, and thus you have an AC induced, which means this galvanometer will point back and forth. We clear with this one? So you have described that the needle keeps oscillating, and then you have explained, okay, that the number of field lines are cut, EMF induced when it goes back, it's cut in the opposite direction, therefore EMF induced in the opposite direction. Okay, for the child with this question, are we clear?
Okay, I've got a thumbs up.
Okay, the next one, where you have wave fronts. See, you people, what you all need to do is these are the basic steps. Extend this. This is your direction of the wave travel, which means technically this is your incident ray. This is your interface. So what you need to do is first draw a normal. This is your angle of incidence. Then you see it's going from deep to shallow. Remember low, which means your speed will decrease. And whenever the speed decreases, it's going to bend towards the normal. So this ray, instead of going straight, it will now bend towards the normal, which means something like this. Okay, I don't really have a protractor, but yeah, something like this towards the normal. Now your new wave fronts will lie on this, right? Because your wave fronts are always perpendicular to this wave travel. So what you do is, if this is your ruler, now I can't explain you at the moment, but yes, if this is your ruler, keep it on this, and then you drag it until you reach the first wave front. Okay, which means your rays are going to, or your waves are going to bend slightly like this. This is what you need to show. We clear? Measure the distance. You can draw your third wavefront over here at the same distance parallel to the first one. How do you check whether it is correct or no? Automatically, you know that your speed has decreased, which means your wavelength will also decrease. Just by looking at the diagram, you will come to know whether your diagram is right or wrong. Okay, just follow simple steps. Step 1, extend this until it hits the interface. Step 2, draw the normal. Step 3, hunt for what's happening, whether the speed will increase or decrease depending upon the change in medium. Step 4, draw the new position. Step 5, drop the wave front, which is going to be perpendicular to the direction of the wave travel. And then just keep dragging your rule, which means your new wave fronts should be parallel. So something like this. Okay, if the question would have been, it is going from shallow to deep, step 1 remains the same. Step 2 remains the same. Step 3, it will bend away from the normal, make it bend away. Step 4 remains the same, drop the wave front. Step 5, click and drag. You see they're parallel, which means now automatically you will see that the wavelength has increased. Hanji beta, tell me.
Sir, you drew like from shallow to deep.
Ah, my lal, I did from deep to shallow. Then I said, let's assume it is going from shallow to deep.
Sorry, sir.
It's okay, no stress. Okay, so I explained you both. We clear, bachas?
Yes, sir.
Okay. What y'all do is you people drop a normal here and then make it bend. That's wrong. Paap lagega. The next one, ninth one, all of y'all understand this. A box is initially at rest. Okay, so it has GPE at the top. It slides down. Very good. So whilst it is sliding down, the GP is getting converted to KE. But is all the GP getting converted to KE, or some of it is getting lost in friction? If you look at this, along with 10 joules of friction. Okay, for such work energy questions, find out the energy at the start, the energy at the end, and if there is energy lost, which means it will be compensated from the energy at the start. So all your GPE gets converted to half mv square along with 10 joules of friction. Okay, GPE you can find out mgh. So 20 into 2 minus 10 joules is half mv square. When you solve this, you should get the answer. This energy lost due to friction, treat that thing as tax. Initial energy, treat it as your pocket money. We clear with this one? Shall I
Yes,
move
sir.
on to the next one, Bachas? Can somebody read this entire question, please? Where the car is, I believe it is decelerating.
Yes, sir.
Okay, so it's a speed time graph. Remember, whenever they give you a speed time graph,
Excuse me. The question is the
hmm
under one. Which moving object has
sorry.
resultant force? The question is about
Oh, the
the
next one.
second
Okay,
option.
the next one. Okay, I'm so sorry, so sorry. The next one. Chalo, let's do this. So, which moving object has a resultant force? Remember, wherever there is a resultant force, there has to be an acceleration. And whenever you talk about acceleration, acceleration means what? Change in velocity, right? And velocity will change either when the speed changes. Remember, velocity is vector. So it is not only dependent on speed, it also depends upon direction. So when the speed changes or the direction changes, the object will undergo a change in velocity, which will undergo acceleration, which will be because of a force. Now, if you look at the options, three options will talk about changing speed with same direction. Only one option will have a change in direction. So if I go through the question, see a
The
diver rising vertical. There is no change in direction and constant speed. Are you all understanding, beta, what they're doing? So over here, this is wrong. Circling. Whenever you circle, there is a change in direction, which means this requires force, which is your centripetal force. The other two options, going up straight. Again, my direction is same, speed is same, which means there is no acceleration, and so is the last one telling you that you're descending at terminal velocity. Now they have not used the word constant speed, but rather terminal velocity. Terminal velocity itself happens when your resultant force becomes zero. So even D is out. Now for the child who told me to speak about centripetal force, what y'all need to know is where is the direction of centripetal force? You will not say inwards. Rather, start using this. It is directed towards the center. Okay, even though they mean the same, use towards the center. Also remember, force and acceleration have the same direction. Motion and acceleration, the direction may or may not be the same. But force and acceleration have the same direction. So if your force is towards the center, the acceleration also needs to be directed towards the center. Okay, these are the two things you need to know. Apart from this, if this centripetal force vanishes, then the object will go in a straight line. That's the third thing you need to know. Everybody has used a rounder, I'm assuming. Okay, now after this session, just take a rounder, radius 5 centimeter, just push the pencil forward. The same thing happens in circular motion. The object wants to go straight, but there is a force which is pulling it inwards. And that is the mechanical force over here that the rounder is exerting on the pencil. Okay, so you need to know this. What is exerting force? So it would be either friction between the tire, or it could be tension whenever you have a string and an object being whirled. It could be the electrostatic force of attraction for an electron, or it could be gravitational force for celestial bodies. We clear, bachas, with this one and the resultant force question? Shall I move on to the next one?
Yeah, we have got thumbs ups.
Okay. So
But
the electricity supply. Tell me.
sir, so you told that because of centripetal force, the object is always changing direction and therefore is accelerating. And
Correct.
back long back, you told that if the force is applied perpendicular to the object, there is no work done. How is it
Hmm.
possible? But sometimes when I apply force sideways to a car, it can topple if I had enough force. How is there no work done? The car
Ah,
moves.
see, when you talk about toppling, you're talking about rotation. I am not talking about rotational dynamics over here, my friend. I'm talking about circular motion, two different things which look the same. We clear?
Yes,
And even when you talk about moment of force, see, the only reason why moment is, or the SI unit of moment is not the same as work done, despite having the same formula, is the angle where you're exerting the force. So just because there is a force acting does not mean that, uh, what do you say? It will change energy. Like when you're lifting the object and you're walking, let's assume you have a bag which you have lifted and you're walking. The work done by gravity is zero, even though gravitational force is acting. So it all depends upon the angle, beta.
but suppose somebody basically pushes a toy near me and I push sideways on the toy at a right angle, it deflects. It makes it.
If it moves, then yes, you are doing work. Then the work done by the guy will be zero, because now, because your displacement is upwards and his force is perpendicular, his force is not doing any work. Be clear?
Yes.
Okay. Anything else?
No. But
Now,
basically, basically,
go
I had
ahead.
a doubt in an ATP question.
Can I clear this one and then I come to your ADP question? Will that
Yes,
work? Okay,
yes.
you can share the ADP question, beta. Whilst I do this,
Okay.
all of y'all mark this as an FAQ, please. Because if you have a question on transformers, this will come for 3 to 4 marks. Okay. Now, this over here, what you're supposed to write is how exactly a transformer works. Now, for y'all, what you need to know is transformer has got three major parts: the primary coil, the core, and the secondary coil. Input, wherever you give, is your primary coil. So, what you will write is, you may take a screenshot at the end, that an alternating current in the primary coil produces an alternating magnetic field in it. Okay. Now, to make it more efficient, we have a core. So what the core does is, the core links the magnetic field of primary with the secondary coil. And this is what happens at the secondary coil. Because it's an alternating magnetic field, the number of field lines are changing, or the field lines are being cut. Okay, so the secondary coil cuts the magnetic field lines and EMF is induced. This is what you need to write. Why do you use soft iron? Because soft ions are soft magnets, the domains align and de-align easily. And that is how it amplifies the magnetic field.
Everyone please note that only 10 minutes of the session are left. So make sure to prioritize your doubts and ask the most important ones only.
Anything else?
We can pick something from the chat. I think many people had doubts in left and right hand rule.
Yeah, that's what I was.
Uh, See, like I told you, Ritik, it would be slightly difficult for me to teach the left and right hand rule on the. Can I just record a video for you all and share it? Because that would be much better. Because
Okay,
I'll have a camera and you people will. Yeah, I'm so sorry for it.
correct. All right,
That
no issues.
works?
And one more thing that was common was Hubble constant. So if you
Hubble's
can
constant. Hubble's
divide,
constant.
yes,
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 and the
yes.
age
Let's
of the
talk about Hubble's
universe.
constant. Okay. So I was making a video on Redshift as well, but because of lack of time, I'm not able to make it. Now, what we need to know is, see, the universe that we have, as per the science, as per what data we are collecting, we know that the galaxies are moving away from us, except for Andromeda. Now, you people think why Andromeda is coming. I will only stick to the syllabus. So you all think why Andromeda is coming towards us. I'll only stick to the syllabus. So the universe is moving away from us. There was a group which was led by Hubble. They were constantly studying the distance between us and the galaxies and the speed by which the galaxies are shifting away from us. And when this data was plotted, obviously it was a scatter graph. When it was plotted, this is what they obtained, which told us that the velocity by which the galaxies are moving away is proportional to the separation between us, which means galaxies that are further away from us are moving at a higher pace as compared to what the galaxies that are near to us are. Okay. Now, this is the proportionality, my friends. Remember, you cannot do anything with proportionalities. You need to make this in the form of equation. So when you replace it, it was said, or the what do you say, the constant, which he labeled as Hubble's constant, obviously because it was his work. This value came out to be as mentioned in the syllabus 2. No, wait. Anyone who remembers what's the Hubble's constant value? I told you all this is the only value to tell you.
2.2 into 10 raised to minus 18 per second, like
Very
that.
good. Okay, so it is 2.2 into 10 raised to minus 18 second inverse. Are we clear? However, remember this value will keep changing over time, so we'll not talk about that. And if you're wondering, sir, how can a constant change? Speed of light is also a constant in a medium. It's not a universal constant, remember. Okay. So apparently, 1 upon this constant gives you the age of the universe. The only mathematics over here is this is in second inverse. So when you find the age, you will get it in second. And then you have to convert it to years. Okay.
Yes, sir.
Go ahead. The next doubt. Life cycle of a star. I would tell you all to strictly refer to the syllabus because over there the answers are given pointer wise. What you need to know briefly over there is what is the protostar, which is the initial stage of a star. What happens when a star becomes a stable star in terms of forces and pressure? When it dies, what happens? Okay, so if it is massive, it turns into a white dwarf, giving out planetary nebulas, and the cycle continues over a period of time. But if it is a supermassive star,
Oh,
okay, the supergiant, yes, then it turns into, or it implodes rather. It implodes. Why implodes? Because your gravitational pull is more, so it implodes into a supernova, forming out either a, what do you say, a neutron star or a black hole at the center, along with planetary nebulas. And the cycle keeps going again and again.
Okay, there's one recurring doubt which is explaining thermistor and filament lamp
Thermistor's filament lamp. First
and the
thing you need to
graphs
know
for it.
is, and the graphs. Okay, so the first thing,
Yes.
my lalis, you need to know about is that thermistors and filament lamp are semiconductors. Okay, they do not obey Ohm's law, which means, so for thermistors, as your temperature increases, your resistance will decrease. And if the resistance has gone down, you need less energy to pass through it. So the potential difference will decrease. Okay, same thing happens for an LDR, except the temperature is replaced with light. So if your light intensity increases, your resistance decreases, and of course, your voltage will decrease. So the graph of temperature versus resistance or light versus resistance will be an inverse relation. And that is why this is known as NTC, but you don't need to know this. Now, when you talk about graphs, can you tell me what graphs are you looking for? Because you people do not have temperature or LDR graphs, thermistor or LDR graphs. So sorry.
The
Are you talking
resistance
about?
graph we have, correct? Filament
Oh,
lamp and the
okay,
temperature and
okay, okay, okay.
resistance.
I get it, I get it. So, chalo, let's do it for a simple wire of a resistor at constant temperature. Okay, for a resistor at constant temperature and fixed dimensions. What I am talking about is basically a resistor which obeys Ohm's law. I will draw two graphs for y'all because in your course, either of it comes. One is V versus I graph. This is V versus I, and the other is I versus V graph. Your syllabus talks about this graph, but sometimes they give you the first graph as well. So if your V versus I graph is this, your IV graph is going to be this. So if this is 30°, this is going to be 30°. Why? Because see, for the first graph, your slope. Now, this is what I want you all to learn. It will be very helpful in your A levels if you're taking or in your IBDP level. Whenever they give you a graph, always see what your y-axis upon x-axis is giving you because that is ideally your slope. So slope in this case is y-axis upon x-axis, which is your resistance. Correct? But in this case, your slope becomes I by V, which is 1 upon resistance. Okay, now sir, why have you flipped 30°? See over here, the line isn't very steep, so your slope is less, which tells us that my resistance is less. Over here, your line is pretty steep, so your slope is more. But in this case, your slope is 1 upon resistance. So 1 upon resistance is larger, but the value of resistance is still small. You see, technically, both the graphs are telling us the same thing. Are we clear? They can do this for any and every question. They can do this for Hooke's law as well. Instead of giving you load versus extension, they can give you extension versus load. Okay, so wherever you have graph, they can flip the axis. Now, but for a filament lamp, the only difference is my temperature, we had made sure it's constant for a filament lamp over a period of time, the temperature will increase. And because filament lamp is made out of tungsten, which is a normal conductor or a metal, it is so for a filament lamp. It's an ohmic conductor till a certain time, which means as your temperature increases, your resistance starts to increase. Okay, as your temperature increases, your resistance starts to increase, which means if it's a VI graph, again visualize V versus I, my resistance is increasing. And for VI graph, my slope is resistance, which means my slope has to increase. And for a I versus V graph, if my resistance is increasing, 1 upon resistance will decrease, so my slope has to decrease. Now you people are smart enough to visualize how a increasing slope graph would be versus how a decreasing slope graph would be. So if the slope is increasing, this is what you have. If the slope is decreasing, this is what you will get. So this is your I, this is your V, this is your V, and this is your I. Yes, for some time it obeys Ohm's law, and then it curves out. Now, if they tell you to find the current, sorry, the slope or the resistance, you will not directly find the slope. You will take the corresponding value of current and its voltage, directly do resistances V upon I and get the answer. Because it's not increasing linearly, you cannot take the slope as resistance. But yes, the slope talks about how the resistance is varying. Be clear with the filament graph. The last graph that you all have is a diode. Okay, so diode, the IV graph, for some voltage, the diode will not work. Normally, it's set to be 0.7 volt. You don't need to remember the value. But after 0.7 volt, the current increases exponentially. This is what you need to know for diodes. In the forward bias, reverse bias, you people do not have. Graphs you don't have, sorry. So these are the types of graph that they will ask you.
Okay.
Uh,
Sir, it's
don't
a
bother taking screenshots. I will just share this PDF in the group. Yes, yes, but I'm so sorry. Go ahead.
yes. Actually, there are a little more doubts than we expected. So, if you are free, available till 6:30, can you take on this class?
I don't mind if the kids are available.
So, Ritik, let's do it till 6:15 because we also have Chem.
Okay, okay. Right, actually,
I don't
yes.
mind. I
So
don't mind.
we'll
Yes, yes.
we'll extend it for 15 more minutes.
No stress.
All right.
Okay, so go
So
ahead,
one of
Bachas. Mm-hmm.
yes. So one of the doubts were Doppler effect. If you can summarize and explain really quickly.
Ah, beautiful. So what y'all have in the syllabus is not really Doppler effect. You kids only have redshift, but for you to understand redshift, you need the idea of Doppler effect. Okay. So let me give the heading as redshift rather.
Yes, sir, definitely.
And Doppler effect. Now, so this is valid for waves. Either sound or light doesn't really matter. But I believe everyone over here, most of us over here are F1 fanatics or MotoGP fanatics, right? We love watching MotoGP and F1 races.
Correct, sir.
So
Yes.
whenever you people are observing the car coming towards the cam and going away from the cam, you will see that the frequency of the sound made by the car, it changes. This is what Doppler effect talks about. Okay, visualize uh anything. Visualize that this is me singing song. So when I'm singing song, what I'm doing is I'm making wave fronts. Wave fronts are basically all the crests of the wave or the troughs, and this is you. You people are going to hear the same frequency as the frequency by which I'm emitting sound waves. So whatever is the frequency of the source, the frequency of the observer is the same. Very good. But now if I start moving towards you, okay, at a decent speed, if I start moving towards you, but to be very frank, at any speed, you will have more number of wave fronts hitting your ears. Can you all visualize this? Because now I am producing sound from a different spot, which is closer to you. So the distance covered needs to be smaller for this wave to reach your ear. Are you understanding this? So what you will hear is more number of waves. So whenever any source is approaching you, Because you are interacting with more number of waves, the observed frequency increases. But if I'm going away from you, if I'm running away from you, now my waves or the number of waves that will reach you is going to decrease. And therefore, if I'm going away, the observed frequency decreases because now my waves are scattered over a larger region or spread out over a larger region. This change in frequency that's happening. See, again, I'm telling you, it's not the frequency change from the source. I am still emitting waves at the same pace or at the same time period or at the same frequency. It's just that because of my movement, the waves appear to be either spread out or near to each other. And this change in frequency is your Doppler effect, where there are two parts, either my frequency increases or my frequency decreases. This is blue shift and red shift respectively. Okay, so if your frequency is increasing, can I say my wavelength is decreasing? Because my speed has to be the same, it's the same medium, and vice versa for this. So when your observed frequency decreases or your observed wavelength increases, this is known as red shift. I am not sure if you people know this, but the entire idea of having the superhero Flash having a red costume was taken from here. Flash had a very bad past, so he keeps running away from it. And if you're running away, your wavelength increases. And therefore, the object appears to be redder in color. It appears, it's not red. Huh? Are we clear with what is redshift and what is Doppler effect?
Yes, I think that was a great explanation. Sir, for the last few minutes, if you can tell us a little tips or what to do ahead for the Feb March coming exams.
So, like I mentioned, what you all need to do is priority, get these pages printed from page number 12 to I guess page number 40, 50 something, wherever the syllabus ends. This is going to be your Bible, wherever it ends. Okay. So, whilst you're browsing through the syllabus, I want you all to mark everything. Say, for example, if I am over here, electromagnetism, whilst I read this, remember if you're writing extended paper, you need to know about core, you need to know about supplement both. Your homework is going to be there are ON papers which are already put up in the group. Pretty legal they are because 24-hour as per Cambridge is the rule. It's been more than months. So you can refer the ON papers which are there in the group. Check how much of it is already mentioned in the syllabus. Nothing will come beyond this. Like there was this question on moment of force. That moment of force measures what? And very few kids actually wrote it measures turning effect of force, which is mentioned in the syllabus. The three sources of energy that do not depend on sun is mentioned in the syllabus. Kids who write what are the uses of electromagnetic radiations, all of it is mentioned here. And especially this page, I want you all to remember it's important. So you all open the syllabus, go through it point by point. You should know that artificial satellites work on microwave, and then these are the two things or two sub pointers. So understand your strengths, your weaknesses as per the syllabus, and then whatever your weaknesses are, work on that, keeping your syllabus in mind. We clear? No point of solving 100 papers and not reflecting on it. Solve 10, but make sure you people know where you have gone wrong. And if a similar question comes, do not make that mistake. So keep a track of your mistakes. Very important. Okay, these are the two things that you kids need to work on. And if possible, revisit the text once. Any textbook, any author works.
Excuse me, sir.
Mm-hmm.
Sir, as you know, the math syllabus has changed a lot. So
Uh-huh.
everyone is saying the sciences will be very hard for Feb March 2025. What do you have to like say on this? Like, do you really think it's gonna be that hard, and the threshold is gonna go really low this time for Feb March?
Thresholds will not go low, my friend. Saisha, Cambridge had released a statement immediately after COVID that they are going to go back to the pre-COVID thresholds. And if you compare 2024 thresholds with 21, 22, 23, you will see it's higher.
Okay,
So
sir.
Cambridge cannot do both. It cannot make the paper difficult and keep the threshold higher, right?
Yes, sir.
Are you understanding? Yes, but now the
Yes.
pattern that I've seen is a lot of theory is coming. Whilst previously it was a lot of numericals, they're focusing more on theory.
All right, sir.
Ritik, unfortunately for A levels, if you look
Hmm,
at the
yes.
threshold and if you look at the winter papers, yeah, they were terrible. It was a shocker. The FM papers were a shocker for Asia.
Yes,
Everybody
yes,
was
yes, sir.
disappointed in physics.
That's why I'm giving
Okay,
major.
anything else? Yeah, smart. Major is better.
Yeah, international
Uh,
papers are written.
yes. So they have to maintain that.
Hmm, correct.
They have to maintain that. O-level physics, if you are in grade 9, writing your paper in 26, I would say yes. Instead of O levels, rather stick to A levels. It's better because a lot of components are now taken from A levels. But if you're in grade 10 already, I would not recommend you all to experiment at the moment. Rather, just analyze on your strengths and weaknesses unless you have the liberty of time and you have already done your homework. Then you may.
All right,
There
I
was
think,
something else.
yes, we will check
Yeah.
it.
It's not hard as such, Lara. It's just that the profile building also takes up a lot of time.
Hmm, hmm.
Yeah, the profile building takes up a lot of time because if you're applying for universities, then they want you to have a solid profile apart from academics. So community service, all the associations that are part of, they will also take up time.
Right. So, this will very much be difficult, easy or neutral.
See, this I cannot predict. I cannot predict, but not demotivating y'all, but IGCSE is the easiest board you can study, my friend.